Case study: Artificial Intelligence in Cybersecurity, Enhancing Vulnerability Identification at Technova. The boardroom was tense as the cybersecurity team at Technova gathered to discuss their recent breach. Their manually intensive vulnerability identification processes had failed to detect the threat that led to a massive data leak. This incident underscored the need for a more advanced approach to securing their systems. David, the Chief Information Security Officer, initiated the meeting by proposing the integration of artificial intelligence techniques into their cybersecurity framework. AI can transform our vulnerability identification processes, he began, capturing everyone's attention. Why is it crucial for Technova to enhance its vulnerability identification processes? Traditional methods, including manual code reviews and penetration testing, are effective but often lag due to their time-consuming and expertise-heavy nature. AI, with its capacity to analyze large datasets and identify patterns, offers a promising alternative. David emphasized the potential of AI to process vast amounts of data quickly and accurately, thus identifying vulnerabilities that might be missed by human reviewers. To illustrate, consider the case where machine learning techniques are employed to analyze historical data on known vulnerabilities. This approach can enable the development of predictive models that identify similar patterns in new software systems. How can supervised learning specifically aid Technova in improving its vulnerability identification? Supervised learning, a subset of ML, can train models on labeled datasets where the outcomes, such as the presence or absence of vulnerabilities, are known. These trained models can then predict vulnerabilities in unfamiliar datasets, offering a proactive solution. David proposed starting with a machine learning model trained on Technova's historical data. This model would learn from past vulnerabilities, enabling it to predict potential weaknesses in new code. The team was intrigued but also cautious. Sarah, a senior cybersecurity analyst, raised a pertinent question. If the training data is biased or incomplete, how reliable would the model's predictions be? This concern is valid, as the quality and availability of training data are critical to the effectiveness of AI models. An incomplete or biased dataset can lead to inaccurate predictions, thereby compromising the system's security. The discussion then shifted to deep learning, another AI technique. Deep learning utilizes neural networks with multiple layers to analyze complex data and can be applied to static code analysis. What makes DL particularly effective for static code analysis in identifying subtle patterns and anomalies? A deep learning model trained on a large repository of code containing known vulnerabilities can detect similar patterns in new code, identifying potential security flaws that might be missed by traditional methods. To implement this, Technova would need to gather a significant amount of labeled code data, including known vulnerabilities. This data would train the DL model to recognize and identify potential flaws in new source code. However, Sarah pointed out another challenge: the interpretability of deep learning models. Often considered black boxes, these models can make complex and opaque decisions, making it difficult for security professionals to understand and trust their predictions. How can Technova address this challenge to ensure model transparency and trust? One approach is to leverage model interpretability techniques that provide insights into how the model makes its decisions. By integrating tools that visualize the decision-making process, Technova could enhance transparency and build trust among its cybersecurity professionals. The team also explored the potential of natural language processing in vulnerability identification. NLP can analyze textual data, such as software documentation, bug reports, and security advisories. How can Technova utilize NLP to prioritize vulnerability management efforts? An NLP-based system could scan through vast amounts of textual data, identify mentions of new vulnerabilities, and analyze their characteristics and potential impact. This information can then help prioritize which vulnerabilities to address first, ensuring that the most critical ones are mitigated promptly. To integrate NLP effectively, Technova would need to develop a system capable of processing and extracting relevant information from diverse textual sources. This system should classify and provide insights into potential vulnerabilities, enabling the team to focus on high-priority threats. David then introduced dynamic analysis, another critical aspect of vulnerability identification. AI-driven fuzz testing, for instance, involves providing a system with a wide range of unexpected or malformed inputs to identify its responses. How can AI-driven fuzz testing be more effective than traditional methods in uncovering multi-step vulnerabilities? By learning from past tests and continuously adapting its approach, an AI-based fuzz tester can identify complex vulnerabilities that require specific input sequences to exploit. The team agreed to pilot an AI-driven fuzz testing tool, which would continuously learn and adapt to identify new vulnerabilities. This dynamic and adaptive approach would enhance their capability to detect vulnerabilities that traditional methods might miss. As the meeting progressed, the team discussed the integration of AI techniques into their continuous integration/continuous deployment pipelines. How can embedding AI-based tools within the CI/CD pipeline enhance real-time vulnerability identification and mitigation? By integrating AI-based static code analysis tools into the CI/CD pipeline, Teknova could automatically review code changes for potential vulnerabilities before deployment. If a vulnerability is detected, the system can alert developers and provide remediation recommendations, thus preventing security flaws from entering the production environment. Despite the clear advantages, the team acknowledged several challenges, including adversarial attacks where malicious actors manipulate inputs to deceive AI models. How can Teknova mitigate the risk of adversarial attacks on AI models? Continuous monitoring and updating AI models with new data and techniques are essential to improve their robustness and resilience against such attacks. Regularly retraining models and incorporating the latest threat intelligence can help maintain their effectiveness. In conclusion, the integration of AI into Teknova's cybersecurity framework presents a transformative opportunity to enhance vulnerability identification processes. By leveraging machine learning, deep learning, and natural language processing, Teknova can improve the accuracy and efficiency of identifying potential vulnerabilities. However, addressing challenges such as data quality, model interpretability, and adversarial attacks is crucial for successful implementation. By continuously refining their AI models and integrating them into CI/CD pipelines, Teknova can strengthen its cybersecurity posture and proactively address emerging threats.